So now we want to talk about different types of equations. So far the ones you've looked at, you've written, you've seen are called molecular equations. So these type of equations, these guys describe the chemicals put into the water and the product molecules. So this is what you're used to seeing. So an example would be if you just have a precipitation reaction, what we just wrote, would be an example of a molecular equation. So molecular equations usually just have this guy plus this guy goes to two things. So this is an example of a molecular equation. It's pretty straightforward. This is that, and it's reacting together. Now the next type that you haven't seen are called complete ionic equations. So complete ionic equations are a little bit more detailed, and they are going to tell me a little bit more. So all my molecular equation does is it tells me that this was put in water, this was put in water, and these products were made. This is dissolved in water, that's a solid. But it doesn't really tell me what's happening at the molecular level. It's not actually giving me a lot of detailed information. So a complete ionic equation is going to describe the actual dissolved species. So it's going to show me visually what's actually happening with something when it dissolves, when it's in an aqueous state. So the way that I do this is I take anything that has an aqueous state, and all the aqueous compounds are going to be written as ions, because what happens is when I dissolve this KOH in water, it breaks apart into ions. So showing it like this doesn't actually tell me what is actually happening. What's actually happening is these ions are floating around in water. So anything that's aqueous is going to be written out. Anything that's a solid, a liquid, or a gas are going to be not separated. These guys are just left alone. So I only separate those that are in aqueous state. So say I have this molecular equation and I want to go from this molecular equation to the complete ionic. So what I do is I look at it and say, okay, this is aqueous. So I have to take anything that's aqueous and separate it into its ions. So I have to figure out, since there's three, what are the two ions? So is it here or is it here? Well, I should kind of know that K is going to be by itself and OH is a polyatomic ion. So I should see, oh, it must be K and OH. Well, what is the charge on K? The charge on K is a +1 and OH minus a -1. Since it's aqueous here, they would be aqueous down here. It keeps its state. But I also need to balance it. In one KOH, I only have 1 and 1. But there's 2 KOHs, which means there's 2 Ks and 2 OHs. So I kind of balance it as I go. 2 K pluses, 2 OHs. So this I find is helpful to kind of write it as you go. So 2 K plus ions and 2 OH minus ions. So now I go to the next one. The next one is aqueous. Since I have my parentheses, I kind of know how I'm going to separate it. The Mg is going to be here. The NO3 is going to be my ion. So I'm going to separate it out with the Mg and the NO3. So then what's the charge on the Mg? Mg is in group 2, so he's got a +2, and since he's aqueous there, he's aqueous here. NO3, I look on my polyatomic ion chart, and I realize that he's a -1, and since he's aqueous up here, he's aqueous here. So now I have the 2 ions. So now I say, well, how many Mgs do I have? I don't have a coefficient, so just look at the equation itself. In this equation, I have 1 Mg because the 2 only goes to everything in parentheses. So I have 1 Mg, so you could write a 1 if you wanted. I have a 2 here, which means there's 2 of these NO3s. So plus 2 of the NO3s. So that's everything on the left side. So now I've taken everything on the left side and I've broken it apart. Now I go to the next thing, aqueous. So that means I separated. So I got to figure out, since there's 3 elements, is it this or is it this? Well, that looks about right based on I already said there was an NO3. So I'm going to have the K and then the NO3. K is in group 1. It's going to match here. K is going to be a +1. NO3 is one of my polyatomics, which is a -1. Since it's aqueous, they're both aqueous. And then I got to balance. In 1 KNO3, I only have 1 K plus and 1 NO3. But I have 2 of those. So that means there's 2 Ks and 2 NO3s. So I got to put those coefficients here as I go down. All right, next is my MgOH2, but he's a solid. So solids are not separated, they're left alone. So then I just write plus MgOH2 solid. All right, and that's it. So for a complete ionic equation, you have to take everything that is aqueous and break it apart into the ions. If it's a solid, a liquid, or a gas, you leave it alone. So I know this is really long and tedious, but it shows you that these are ions floating around. It's not the actual compound floating around. Now, in the next lecture, I'm going to talk about another type of ionic compound, ionic equation that we can get after we write the complete ionic equation.